Welcome to Dan Makes Things. My name's Dan and I made a companion robot. This is part 2 of the series, and in this video I'm going to talk through the construction of the robot and the components used. If you missed the video of the overview, then feel free to check out the link in the description. This is the teardown of the body. It's a statically stable bipedal design. It has 3 servos per leg with a 3D printed PLA structure, and the servos are attached directly to the PLA via screws. On the back of the robot there's a USB-C port, and that's the only power source required. There's space for a LiPo battery, but that involves removing the rear panel and swapping out the USB-C module. It's designed to fit this 3-cell LiPo. The runtime is only around an hour, so it isn't something that gets a lot of use. The back section is push fit and just pulls away. You can see the slack for the servo wiring is packed in here, and the USB-C power delivery module. This means you can choose which voltage you want to supply it with. Any of the options above 5 volts are sufficient and compatible, as the buck converters can handle up to around 20 volts. Disconnecting the front, you can see the voltage display and a bank of capacitors. This is to ensure that when the relay activates power to the servos, the supply to the Arduino isn't interrupted. This was a problem in the past, and this solution is a temporary workaround, but it seems to resolve the issue. There's also a fuse that will kill power to everything if there's a problem. The unused pins are used to connect the Raspberry Pi and the head. If we tease the PCB out gently, we can see, once we move the wires out of the way, an Arduino Pro Mini. That only needs to be accessed if you need to press the reset button while programming it from the Pi. There's a voltage divider which is used for battery monitoring. Just make sure to pick the appropriate resistors for the voltage you're providing, as the Arduino can't accept more than 5 volts on any input pin. This is the relay that controls power to all the servos. This is the main voltage input and the voltage display. Everything runs through the single fuse and then via the 2 buck converters, which are set to 5 volts for the Arduino and servos and 5.1 volts for the Raspberry Pi. The head is also PLA and contains a Raspberry Pi with a custom PCB. As you can see, we have the camera attached to the CSI port. It has 160-degree field of view, it has a small array of neopixels for the RGB output. The cables are to connect the Pi to the body PCB for power and serial communication. This is the custom PCB that's attached to the Raspberry Pi. The header pins continue through the PCB so that any unused pins can be utilised in future. On the underside there's a buzzer for audio output and 2 MEMS microphones for audio input. There is an issue with the OS that's preventing audio input in the current version, but I'm looking to resolve that in future. There is a microwave sensor used to detect motion. We'll cover that in more detail in the next video. There's also a tilt switch that detects whether the Pi is being turned upside down. This is used as a safety cutoff that initiates an immediate shutdown of the Pi. As you can see, the microwave sensor goes into the antenna of the head. In order to fit this in place, we need to disconnect it from the Pi, and in this version I'm using DuPont connectors to facilitate that. When we fit the Raspberry Pi into the 3D printed head, you can see there's space for the USB and Ethernet ports, as well as a line screw mount to secure the Pi in place. Next we put the camera in place, which is a case of manually manoeuvring it through the appropriate hole. You'll notice there is a piece of PLA that protrudes from the head here. That's so that there's room for the camera's CSI connection, as otherwise it would put too much strain on the wires. We're going to use some hot glue to fix it in place. Then once that's dry, we can take the cables for the serial and power and push them through the holes to the body. Then we can take the head and secure it to the servo arm directly. It's lightweight enough that this doesn't cause a problem. Then it's just a case of fitting everything in and making sure the tilt switch is pushed into the space on the bottom part of the head so that it doesn't move out of alignment. Then we can close the head pieces together and insert the screws. Next we can reattach the wires to the empty pins. We attach the positive wires to the connectors closest to the back of the robot. Then we just need to pack everything back in. The final step is to attach the visor and vent to the top of the head with glue. In the next video I'm going to be talking through the software in more detail, and if you've missed the first part of the series, please take a look at the link to the overview video in the description below. Thanks for watching.